The European spot for particle exploration, CERN, is uncovering subtleties of another iota smasher today. Something on various occasions greater and 2 times as profound. It has found 3 new particles, which could help us in understanding how our universe was considered and what its future resembles. Scientists at CERN have quite recently revealed discoveries that turn how we might interpret the universe on its head. Underneath the outer layer of their prominent examinations lies a vast expanse of particles and powers so odd they could be straight out of sci-fi. From likely sections to various aspects to particles that challenge the actual groundworks of the real world, what strange mysteries are disguised inside these experiments? Let's jump into the universe of CERN and disentangle the insights that could rethink our universe, the doorway to new aspects. A wormhole could hypothetically show up out of nowhere overhead, and the explanation would be the earth-shattering examinations led at CERN, home of the Huge Hadron Collider, LHC. The LHC is the world's biggest and most remarkable iota smasher, situated close to Geneva, riding the line among Switzerland and France. There are privileged insights about this abnormal association that the world doesn't have the foggiest idea, mysteries that might actually change how we view material science and the universe. CERN, the European Association for Atomic Exploration, works this huge logical instrument. It traverses in excess of 27 kilometers and sits profound underground. The essential capability of the enormous Hadron Collider is to permit physicists to test the expectations of different hypotheses of molecule physical science. This incorporates the high-profile assessment of the standard model of molecule material science, which assists us with understanding the central structure blocks of the universe, i.e. its center. The enormous Hadron Collider works by speeding up protons to almost the speed of light prior to crushing them together. These impacts produce a shower of new particles, which researchers study to acquire experiences into the laws of nature. It was through such exploration that the Higgs boson, frequently alluded to as the God molecule, was found in 2012. This disclosure affirmed how particles gain mass and was an essential second in molecule physics. The tests directed at the enormous Hadron Collider are pivotal for understanding peculiarities that happen under outrageous circumstances, similar to those not long after the huge explosion. The information gathered can see us more about how the universe started and developed, and about the principal constituents of issue. This makes the enormous Hadron Collider a central participant in possibly revealing new components of the real world, aspects that could make sense of secrets encompassing dim matter and the principal powers of nature. Such progressed trial and error at CERN doesn't come without worries. Some theorize about high-energy tests making dark openings or odd matter that could present dangers to Earth. In any case, CERN guarantees that all security means are met, and established researchers intently screens these examinations. Studies and hypothetical models affirm that any risky situations are profoundly impossible. Through its continuous examination and disclosures, CERN assists us with understanding the universe better and exhibits the fantastic force of human imagination and cooperation chasing knowledge. Unveiling the LHC, mankind's cutting-edge miracle. The Huge Hadron Collider at CERN isn't simply a great piece of innovation. It is a wonder of present-day science and designing. Arranged underneath the Swiss-French boundary, the Huge Hadron Collider goes through a passage 27 kilometers in perimeter and as profound as 75 m underground. This makes it the biggest molecule collider on the planet and perhaps of the main instrument in the field of molecule physics. The construction of the Huge Hadron Collider is intended to deal with trials of gigantic scope. The primary ring of the collider, housed in a passage with a breadth of 3.8 m, contains 2 equal pillar pipes. Each line coordinates protons in inverse headings, advanced by a progression of superconducting magnets. These magnets are pivotal for keeping up with the way of the protons, bowing their direction at speeds near the speed of light. Encompassing the pillar pipes are layers of cooling frameworks that keep the temperature colder than space, important to keep up with the superconducting magnets at their required working temperature. The size of the Huge Hadron Collider is likewise featured by its utilization of thousands of magnets, including 1,232 dipole magnets to twist the bars and 392 quadrupole magnets to concentrate them. The biggest and most remarkable superconducting magnets utilized are 15 m long and weigh 35 tons each, exhibiting the huge actual scale and innovative aspiration behind the enormous Hadron Collider. The primary reason for the Huge Hadron Collider is to investigate the essentials of the universe by noticing the littlest parts of issue. By speeding up particles to almost the speed of light and afterward impacting them, the Huge Hadron Collider permits physicists to concentrate on the subsequent particles that are created during these crashes. This cycle helps in testing and growing comprehension. We might interpret the standard model of molecule material science, which is the ongoing best portrayal of the subatomic world point. One of the critical targets behind the enormous Hadron Collider's analyses is to uncover the secrets of the Higgs boson. Its disclosure at CERN in 2012 affirmed speculations about how particles gain mass. The enormous Hadron Collider likewise examines other major particles and powers, intending to resolve essential inquiries, like the presence of dim matter and the idea of the universe soon after the huge explosion. Also, the Huge Hadron Collider looks to check the presence of new particles that hypothetical physical science predicts yet have not yet been observed. These tests are fundamental for possibly finding new physical science past the standard model, including supersymmetry and aspects past the recognizable three spatial aspects. The vision behind the Huge Hadron Collider isn't just to comprehend the structure blocks of the universe yet, additionally to encourage worldwide joint effort. With great many researchers from north of 100 nations cooperating, the Huge Hadron Collider is confirmation of overall participation in the mission for knowledge. The enormous Hadron Collider's construction and scale empower it to handle probably the most significant inquiries in physical science. Its motivation reaches out past simple logical interest, expecting to grow how we might interpret the universe and move worldwide joint effort in science. Through this tremendous and complex instrument, mankind keeps on pushing the limits of what is known, wandering into the quantum realm. But how does the enormous Hadron Collider truly work? At the core of CERN's exploration offices, the Huge Hadron Collider fills in as a strong magnifying lens into the quantum domain, permitting researchers to notice and concentrate on the key particles that make up everything known to man. The course of molecule speed increase and crash at the Huge Hadron Collider is a basic strategy for looking at the underpinnings of physics. Inside the collider, two high-energy molecule radiates travel at almost the speed of light before they are made to impact. These bars travel inside tubes kept at super-high vacuum, copying the states of space. Superconducting electromagnets, chilled to temperatures colder than space, guide and center the shafts at assigned crash focuses along the passage. At the point when these bars meet, they crush particles along with huge energy. The impacts produce different subatomic particles, some of which are profoundly unsound and exist just for parts of a second. To identify and examine the results of these crashes, the Huge Hadron Collider is outfitted with monstrous identifiers: Mapbook, CMS, ALICE, and LHCb, each intended for explicit sorts of examination. These locators catch information about the particles, including their mass, charge, and energy. This information assists physicists with testing forecasts of molecule material science hypotheses, including the standard model, and investigate particles and powers that administer the universe point. One of the huge discoveries at the enormous Hadron Collider was the revelation of the Higgs boson in 2012. This molecule, once in a while alluded to as the God molecule, is critical on the grounds that it gives proof to the Higgs field, which is liable for giving mass to rudimentary particles. The presence of the Higgs boson was anticipated by the standard model, and its revelation was a fantastic accomplishment, affirming well-established hypothetical predictions. Beyond the Higgs boson, the enormous Hadron Collider has likewise been instrumental in finding a scope of different particles. For example, the collider has given proof to the presence of pentaquarks and affirmed the presence of tetraquarks, particles made of 5 and 4 quarks, individually, which had not been seen previously. These disclosures grow how we might interpret hadronic matter, which is matter made of quarks bound together by major areas of strength that keeps the cores of iotas intact. These discoveries exhibit the prescient force of the standard model and open new roads of examination in molecule physical science, offering bits of knowledge into the way of behaving of issue under outrageous circumstances, similar to those soon after the Large Bang. Theoretical dangers: science or sci-fi? As the abilities of the enormous Hadron Collider grow, so do the hypotheses about its likely risks. Two of the most conjectured speculative dangers related with the Huge Hadron Collider are the making of strangelets and the possibility to create miniature dark openings. These situations have caught public interest and logical investigation alike. Strangelets are a theoretical type of issue that is more steady than customary matter. The hypothesis recommends that strangelets could start a chain response, changing over normal matter into more strangelets, possibly Lea.